do with radians in these situations? Transfer to degrees, so I suggest we do that. 7 pi over 12 times what? Nobody knows what we multiply by? A heartbreaking day. This is why. There you go. You multiply by 180 over pi, and the pi's cancel, and you do 7 times 180 over 12. What do you end up with? 105. Can somebody verify that for me? We can't trust that kid. What? Don't do that. Come on, somebody. Can I get a witness on the 105? I do. Yeah. It is 105. Thank you very much. Okay, we'll trust both. All right, tangent 105. Okay, now, if you do this the way I did it second period, because I wasn't paying attention to the directions, if you do this like this, you're going to lose. Isn't that a valid way of doing it? Sure it is, except for one thing. They said you can't use that method because you have to use the half-angle identity. Bruh is right. Okay, I'll get a trash can over here if you need to throw up. That's what it sounds like every time. Bruh. Come on. Okay, half-angle identity formula. Okay, so 105 is half of what? 105 is half of what? 210. 210. So if we want to use a half-angle identity, we're actually going to be using 210 degrees. Hopefully we don't get burned. Okay, so the half-angle identity, well, first of all, I should probably think about a circle here. Where's 105? Approximately. Just give me the quadrant. Quadrant 2? Somebody agree with that? Yep, okay, good. So quadrant 2, we're talking maybe right about it here, 105. What do we know about the tangent in that particular quadrant? Is it positive or negative? It is negative, isn't it? See, in the formula, the half-identity formula, doesn't it start out like plus and minus? Well, guess what? You have to choose whether it's positive or negative. So that's a choice you have to make. If you write down plus and minus, you lose. You have to make a decision. So you have to say, oh, it's negative in that quadrant because all the slopes are negative. That's the choice you have to make. Okay, what's inside? What's inside? You got the formula on the formula sheet, right? What's the formula on the formula sheet telling me? Look back at your formula sheet. See if we can find it. Have a plus minus, does it? Oh, I thought it did. What? Shouldn't it have a plus minus? Or which one do you have here? Yeah, there's 3 versions of it, right? Okay. So there are 3 versions of it. 2 of them, it looks like, take care of the plus and minus for me. And one of them makes me choose. So I guess I was going with the one that made me choose. So what is that one? Mr. Tudor, you had it up there. 1. Cosine. Okay, good. Over. Now, does somebody have a different version of that? There were 3 versions of the tangent half angle. Can someone throw another one at me? Okay? Next person. Yes, Mr. Adams. 1 minus cosine over sine. See, this version actually will take care of the plus and minus for you. You don't actually have to make the decision. You'll end up with a negative number anyway. Okay? So, we do have a couple options here, but you do have to use a half angle, in other words, or to get the credit for this. So, let's see here. Ooh, sorry, I better back up. Alright, so 210, that's like down here somewhere. Gotta use the script. 210 is right here. If I'm doing the first one, what's the cosine of that? What's the cosine of 210? I'll give you a hint. It's a negative number. It's definitely not negative 1/2. Talk to your neighbors. You got about 30 seconds to figure it out. Don't cheat. Think. Look. Think. See what you can come up with. See if they agree with you. If you're at home, I want you throwing it in the chat for me. There we go. Sorry about that. Let's see, we've got a couple of them. Pause. See what your readings are here. So only Mr. Lehman and somebody back here missed one. That's it. It's not negative 1/2. It's not negative radical 2 over 2. It's definitely not negative 1 on the outside edge of the circle, which means it has to be negative radical 3 over 2. I'll do the other one here in a second. And we end up with the opposite of 1 plus. Now, what should I multiply the top and bottom, just so I clean it up a little bit and get rid of the fraction inside of a fraction thing? What can I multiply the top and bottom of that by? I'll give you a hint. It's bigger than 1. Let's go with Mr. Sedlacek. What should I multiply the top and bottom by? Some of you I can't see on camera. You barely see Dalton. You barely see Sedlacek. You can't see Mr. Frank. You know Mr. Frank did answer the question. What should I be multiplying the top and bottom of that by? To get rid of the fractions, so I don't have fraction inside of a fraction. I don't want radical 3 over 2. I don't like a fraction inside of a fraction. So what can I multiply by? About this 2. Let's just get rid of the denominator. Okay? I'm not trying to overly complicate life. I just want to make it look a little bit nicer. So this would be 2 plus what? Come on, we multiplied inside there. We multiplied here 2 plus what? It's radical 3. Okay, and on the bottom, 2 minus radical 3. Okay, and no, I'm not rationalizing that thing. We could, but I think it's a waste of time. Okay, so if I go look at this other version of it, we have 1 minus, you guys told me that was negative radical 3 over 2, divided by the sine of 210. What is the sine of 210? You can go back to my circle if I need to. Sine, that's the y value, right? What is that y value? It is not 1/2 good try, but you're close. Let's see what we got. I know, you're like, yeah, you know what I meant, but... Alright, so, what should we multiply this by, top and bottom? Any cool numbers that we should use to multiply to the top and the bottom of this? 2 would be another great choice, right? That would help me out a lot. So I would get 2 plus radical 3 over what? -1? Yes, that's true. And if you were a super cool person, you might write it like this. Well, believe it or not, those two answers are exactly the same. I'm sure we would have to prove it to you by rationalizing, but I ain't going to waste the time. We only used 2 of the different versions of the tangent formula, so we could have used the other one as well. There were 3 choices of half-angle identities for the tangent. So you would have to pick one of those in order to win, and if you didn't, if you chose to do the sum formula, and there will be people, I'll ask them to use the half-angle formula, and they will start going down that other road, and they will lose most of the credit. Even though they can possibly get the right answer, they didn't use the right identity. Yes, question. You do not have to prove the identity. Folks, that's a great question. All identities that we have to date have been proven and can be used whenever you feel like it. If it says sine 2x, you're going to do 2 sine x cosine x. Nobody needs you to pull out, unless, of course, if it asks for a proof, if it says prove this identity, and they're asking you to use like the sum or difference formula, well then yeah, I can use the simple sum or difference formula to show you that's what it is. But if it's a solving question, no, you're not proving anything. And I'm not going to put any sine 3x's or cosine 4x's. The highest multiple angle you'll see is 2x. Now, the reason is not because I don't think you can handle it. The reason is because you don't have the time to handle it. As you saw from the video, 25 and 27, take your time. 27 takes a lot of time. Okay, what else? Do we have any more half-angle ones in there that we need to look at? Like 33. Do we need to do 33? Yes, no? Yes? Okay, let's do it. 33. All right, what was 33? Is it a cosine or a sine? Cosine 75 degrees, okay? You're instructed to use a half-angle identity for this. What is twice as big as 75 degrees? What's twice as big as 75? 150, so that's what we're using, 150. Where's 75 degrees? Which quadrant is 75 degrees in? That's quadrant 1. Somewhere up here. What do you know about every x value in quadrant 1? Every x value in quadrant 1, positive. So, when I come over here, I must make a choice. I can't put plus and minus. I have to choose, in this case, positive, because we know that all the x's in quadrant 1 are positive. we got underneath that radical? Is it 1 minus or 1 plus? On your formula sheet, what's it say? 1 plus? It is plus? I'm not looking at my formula sheet, so I'm trusting you on that. It's all over 2, correct? All right, I suggest you find, so 150, that's like over here. I suggest you find its cosine. Go. Right on your Go formative or on your paper. Look at what you got. So the square root of 1 plus negative radical 3 over 2, which many of you did get negative radical 3 over 2 divided by 2. You knew that this was negative radical 3 over 2 for the x value. Okay, and I suggested you clean it up a little bit by multiplying the top and bottom of that by a value such as, now remember this is all inside the radical. We can multiply by 2 over 2 because that's really only multiplying the inside by 1. So that's going to give us 2 minus radical 3 over 4. Now there is one thing that you could do with that, and it has something to do with that denominator. We could simplify it, couldn't we? So here's my question. Is this the same answer? Okay, make a decision on whether you think that's the same answer or not. Talk to your neighbors and see if that is bigger or is that the same thing that I'm suggesting you can do with that? Talk with people. Okay, fair enough. I appreciate the honesty. See what the people online think. Let me rewind that. What if I wrote this? 2 minus radical 3, obviously under the radical, and then I wrote the square root of 4 underneath that. What is the square root of 4? 2. 2 minus the square root of the quantity 2 minus radical 3 all over 2. Is this the same thing as that? The answer is yes, it is. So that's the only thing you could do to simplify that a little bit more. Now, if somebody wrote it like this, would I have a problem? No. Not at all. And it was positive. We had to make that decision.